This is one of a series of 6 general revision videos for higher tier maths GCSE. I'm basing this work on the pixiemaths.co.uk revision mats, which are divided into 6 different topics. So this is the shape, space and measure revision mat. And I'm just going to be working through the questions in the way that makes most sense to me. So I'm not going to be teaching topics, I'm just going to be explaining my working as I go through. So first of all, vectors. Some of these need more space to answer, so I've kind of separated out the questions a bit. So here we've got OABC is a parallelogram. P is the point on AC such that AP is 2/3 of AC. So we've got to be a bit careful about this. AC is the whole length, and that is divided into 3. That is, sometimes it's given as a ratio, but in this case it's given as a fraction, so we have to be careful about how we notate this. I would just put a 2 there and a 1 there, giving a total of 3/3. 2/3 is this bit, and 1/3 is the remaining PC bit. We're also told, as on the diagram, OA is 6A and OC is 6C. Find the vector OP, give your answer in terms of A and C. So OP, I need to think of a good route for this. OP, I would need to go, I'm going to say let's go OA and then AP, and that's going to get me from O to P. So OP equals OA plus AP, and OA I already know is 6A in terms of A. AP I know is 2/3 of AC. So I'm just going to leave that in this kind of notation to begin with, 2/3 of AC. Still using OP, 6A plus 2/3 of, and AC is minus 6A plus 6C. So expanding that bracket, 6A minus, so 2/3 of 6A is 4A plus 4C. And of course I can subtract those, so that gives me finally OP equals 2A plus 4C. Question 2, the midpoint of CB is M. So I've got M in here. And it says prove that OPM is a straight line. So to prove that things are a straight line, I need to show that they have the same gradient. So OP should have the same gradient as PM or as OM. So I can work with any of those. They should have the same gradient. And then because they have a shared point, so if I compare OP and OM, they share point O. So if they're parallel, they will be on the same line, or collinear is the word that we are looking for here. Collinear. So I'm going to start off by, I've got OP from the first question. I'm going to look at a way of using, I'm just going to use OM. So OM is, I can get there by going OC and then CM. And we know that all of this is a parallelogram, so that is vector 6A as well. So OM is OC plus half of CB. I'll just write it like this first of all. OC plus CM. And then I can see using my chain of letters that I'm going from O to C to M. Then I'm going to redefine CM as half of CB, which is OC is 6C plus half of CB, which is 6A, half of 6A. So that equals 6C plus 3A. So if I'm looking at comparing these, I would say that OP is 2 lots of A plus 2C, and I can say that OM is 3 lots of A plus 2C. If I factorize that bit, that would be in brackets 3 2C plus A, which is what I've got here. So therefore OP and OM are parallel. Both go through O, as in it's a shared point O. So OP and OM are collinear. Therefore, OPM is a straight line. Okay, so that's the vectors bit, and that's not the hardest thing in vectors, but it's in general that topic of vectors, proving that things are parallel and collinear, is getting towards the more difficult end of the whole GCSE. Okay, similarity and congruence. So in this first question, we're told that the straight lines AE and BD intersect at C. That's important. It's exactly what it looks like, but it tells us that this is one straight line and that is one straight line. Prove that triangles ABC and EDC are congruent. So normally in these situations we are told that AB is parallel to DE, but we haven't been told that here, so we can't assume it. And because we can't assume that, we can't assume that any angles are the same. So we have to try and find somehow, if we're trying to prove congruence, we are either trying to use SAS, SSS, ASA, or RHS. Now, because I've not given any angles at all in the right-hand triangle, I do know that this is the same angle as that. They have to be, they're vertically opposite angles. So in order to use SAS with this, I would have to find the length of this side. I do have two sides here, so again, potentially, if I were going to use SSS, I'd have to find both sides, and that would only be possible if these are parallel, which we don't know that they are at the moment. I don't have a right-angled triangle, so I can't use that. And angle, side angle, I don't have until I know that those are parallel or not parallel. So I'm basically stuck with probably SAS for this. So if I look at what's available, I can find this missing line, length of line. I'm going to have to use the cosine rule, so it's a fairly complicated question, but if I can find that that length is also 7 centimeters, then I'll be able to prove that the triangles are congruent using SAS. So that's going to be my first thing, is to try and find the length of AC. So cosine rule tells me a squared equals b squared plus c squared minus 2bc cos A. And remember that the A angle and the A side are the sides of the odd ones out kind of thing. So we've got A angle there, gives me A side here. So that tells me AC squared equals B squared, which can be 3, plus C squared, plus 2 times 3 times 5 cos 120, cos 120. And again, AC squared equals 9 plus 25, and cos 120 is minus a half, so if I type cos 120 into my calculator, I get minus a half, times that by 5 times 3 times 2, gives me minus 15. So A squared equals 9 plus 25 minus 15. Feels like something's gone wrong there. Oh, I know what's gone wrong. B squared plus C squared minus 2bc cos A. That's a major mistake. So that should have been minus all the way through. So obviously you're given that formula on the formula sheet, so make sure you copy it from the formula sheet without making the mistake that I just made. So when that is minus, cos 120 is minus a half, so that all comes out as, instead of minus 15, plus 15, which gives me 49. Therefore AC equals 7, that's much better. So if AC is 7 centimeters, therefore we have, in order to prove our side angle sides, I've got AC equals CE equals 7 centimeters. I've got BC equals CD equals 5 centimeters. And I've got angle BCA is equal to angle DCE. DCE. Vertically opposite angles are equal. And therefore I've got side angle side. Therefore ABC and EDC are congruent. Okay, next question. Cylinder A and cylinder B are mathematically similar, so that just means that they're scaled up versions of each other. Everything is in proportion. Volume of cylinder A is 80 centimeter cubed. Calculate the volume of cylinder B. So for these kind of questions, we need to remember that we're looking at a linear scale factor, an area scale factor, and a volume scale factor. So the linear scale factor that would take me from A to B, from 4 to 6, is 6/4. We'll just take those two, which is the same as 1.5. So I take A, multiply it by 1.5, and I will get any length on B. If I was going to use an area, I would take any area on A and times it by 1.5 squared to get my scale factor. And for a volume, I need to times that by 1.5 cubed. So I need to take my, that would be 1.5 cubed. So the volume of B is the volume of A, 80 times 1.5 cubed. And that is 270 centimeters cubed. Okay, circle theorems next. So the diagram shows a circle, center O. A, B, and C are points on the circumference. DCO is a straight line. DA is a tangent to the circle, and angle ADO is 36 degrees. So everything is as it looks, but we do have to remember to check that this instruction makes sense. We've got a tangent and a radius, and we need to be sure that they are as they look they are. Work out the size of angle AOD. That's this one here. It doesn't tell us to give reasons, but I will explain the reasons as I go. So angle DAO is 90 degrees, and we know that because of the reason that a radius meets a tangent at 90 degrees. And so the angle we're looking for, AOD, equals 180 minus 36 minus 90, which equals 54 degrees. The other reason I would have to give in there is because angles in a triangle add to 180. So we've got a 54 degree angle in there. Work out the size of angle ABC, which is up here. For this one, I'm going to compare it to angle AOC. Even though they've overlapped, these two angles are in the same segment. Well, there's an angle at the centre, they're subtended from the same points, from the same A and C, from the same arc. So I would use my theory that the angle at the centre is twice the angle at the circumference. So ABC is half of 54. So that gives me 27 degrees. That's because the angle at the centre is twice the angle of the circumference, subtended from the same arc, which is arc AC in this case. Next question. In the diagram, A, B, C and D are points on the circumference of a circle. If I've got 4 points like this, I know I'm immediately thinking of cyclic quadrilaterals, or cyclic quadrilaterals, and that the opposite angles in a cyclic quadrilateral add to 180 degrees. We've got angle BAD as 70, we've got angle BOD as X, and we've got angle BCD as Y. So working out the value of X, I'm going to use that again. Angle at the centre is twice the angle at circumference. They're from the same arc BD. So X equals 2 times 70. It's 140. Value of Y, 180 minus 70, because opposite angles in cyclic quadrilaterals add to 180 degrees. So 180 minus 70, Y equals 110 degrees. Okay, volumes of pyramids and spheres. For this, in the exam, you would actually be given the formula printed in the question. It's not on the formula sheet, but it would be printed in the question. So, volume of a sphere is 4/3 pi r cubed. Surface area of a sphere is 4 pi r squared. So, volume calculation, 4/3 times pi times 6 cubed. Making sure that you cube the 6 before multiplying by anything else. That is 288 pi. Which is 905, well I'll put 904.77, etc. Which is 905 centimeters cubed to the nearest centimeter cubed, or to 3 significant figures. Surface area, similar process. We've got 4 times pi times 6 squared, which is 144 pi. Which is 452.389, etc. So that is 452 centimeters squared for area this time. Right, the pyramid. Volume of the pyramid is going to be quite straightforward, but the surface area of the pyramid is a lot more complicated. So volume of a pyramid is 1/3 times the corresponding volume of the cuboid. So I always think of any pyramid as being 1/3 of the cuboid that it would fit within. So 1/3 times the area of the base times the height. 1/3 times 5 times 7, the area of the base, times by the height. Which is 280 over 3, which is 93.3 centimeters cubed to 3 significant figures. Surface area, we're going to have to break it down into all of its faces. So the base is 5 times 7, 35 centimeters squared. And then I have, it's quite confusing this one because it's drawn off center, which means I technically actually can't calculate the surface area of this because I don't know where this point is. If it was in the center of the shape, and I'm going to have to assume it is to calculate the surface area, that gives me a triangle on this side with a base of 7, and on the other side a triangle with a base of 5. And now it might feel like the height of that triangle is 8 and 8, but actually they're not, because they've been leaned in. We can see that this triangle here, this length here, is not 8, it's going to be longer than 8. And in order to find that, I need to think about this triangle with a height of 5, and if that's 8 and that's 2.5 in a right angle, then I can find this missing side. So 2.5 squared using Pythagoras plus 8 squared. And square rooting the answer, giving me, I'll just call it 8.382. Square root of that, 8.382. So that length, 8.382, is actually what would happen if I've got this base of 2.5 and the height of 8 in the middle, which is very confusing, this picture. If I'm looking for this length here, I'm thinking about that triangle with its base of 2.5 and its height of 8. And so this length here on the triangle with 7 is 8.382. And if I'm going to find this length here, I'm thinking about the triangle that has a height of 8 and a base of half of 7, so 3.5. So in this case, to find that length, I would use Pythagoras and do square root of 3.5 squared plus 8 squared. And that gives me when I square root the answer, I get 8.732. So that tells me that this length here is 8.732. This is all really complicated, by the way. This is an advanced question when it comes to surface areas of pyramids. In general, you'd either be given more information at the start, and particularly you'd be given this as a right a pyramid with something in the center, this 8 centimeter in the center rather than to one side. So this is generally harder than you would see in a GCSE paper, but it's not impossible that it would appear in a GCSE paper. Not impossible at all. So I've got my triangle now with, this triangle has a base of 5 and a height of 8.732, and I've got 2 of them, one on each side. So I've got half times base times height, and 2 of them. And then I've got the other triangle on this side with a base of 7 and a height of 8.382. And I've got half times base times height of them as well, and 2 of them. So putting both of those in, $43.66 and $58.67. So that's 674. So the total surface area is the base plus all 4 sides of the pyramid. So much more complicated than it looks, finding the surface area of a pyramid. But the volume of the pyramid at the start was really straightforward, just 1/3 times the base times the height. The volume and surface area of this shape. So the volume of a cone, we need to think of first of all of what we're dealing with here. If that's a radius of 6 centimeters, then that is also a radius of 6 centimeters, which means that this height of the cone is 20 minus 6, so that's 14 centimeters. So volume I've got volume of the cone is 1/3 pi r squared h. I've got, it's a third because it's a kind of pyramid, it works in the same way. 1/3 times pi times r squared is 36, well 6 squared, times 14. It's 168 pi. And the volume of the hemisphere underneath, hemisphere is half a sphere, is a half of 4/3 pi r squared. Pi r cubed, I mean. 4/3 pi r cubed. Times by r cubed, so again radius of 6, which is 144 pi. So total volume (144 plus 168 pi) is 312 pi, which is 980 centimeters cubed to 3 significant figures. The surface area of this, in order to find the surface area of a cone, we need to consider pi r L, where L is the slant height. And we can work out the slant height of this one because we've got a height of 14 and a base of 6. So the slant height is going to be the square root of, so L, this length, is the square root of 14 squared plus 6 squared, using that Pythagorean method to find the hypotenuse, which is 2 root 58, I'll leave it as I said. So pi times r times L is going to be the surface area of the curved surface of the cone. Normally with a cone we'd also be adding the base, but because this base is part of a hemisphere, and like there's not an out, it's not a space that we need to include in the surface area because it's not the outside of the shape. So all we need for the cone is pi RL, which is pi times 6 times 2 root 58. Which is 12 root 58 pi. And then we've also got the hemisphere. So we're looking at the curved surface area of half a sphere. So that is half times by 4 pi r squared. And again, r is 6, so we've got 36 times 2, 72 pi there. So total, I'm just going to add those together, 72 pi plus 12 root 58 pi gives me 513 centimeters squared to 3 significant figures. Okay, Pythagoras' theorem and trigonometry. So this is straightforward SOHCAHTOA trigonometry, because it's in a right angle triangle. Work out the value of x. I start by labeling my sides. Compared to x, I've got hypotenuse, as always, opposite, and adjacent. The ones that I know about are op and height, so I'm going to be using sine. Because that's the one that includes opposite and hypotenuse. So I've got sine x equals 3 over 10. X equals sine to the minus 1, 3 over 10. which is 17.457. X equals 17.5 degrees to 1 decimal place. Work out the value of y. I can do that either using Pythagoras' theorem. Y squared equals 10 squared minus 3 squared, which is 91, and therefore y is root 91, which is 9.54 centimeters, correct to 3 significant figures. The other way to work out y would be to use again your angle of 17.5 degrees and either cosine or tan and the sides that are on the other sides of the triangle. But either way, we should end up with this angle, this length of 9.54 centimeters for y. Okay, on the shape below, use the cosine rule to calculate angle x. So you've got some options here. On the formula sheet, we know that the cosine rule is given as a squared equals b squared plus c squared minus 2bc cos a. And that's the only version of it that we're given on the formula sheet. Some of you might have memorized cos a equals b squared plus c squared minus a squared over 2bc, which is the same formula just rearranged. Now if you've memorized this one, then it's probably easier to use that because we're looking for a missing angle. However, this is the one on the formula sheet, so this is the one I'm going to work through and solve using this. So we remember that a squared, the side that we're looking for, or that we're linking, is always opposite the angle that we're dealing with. And b and c are interchangeable sides. So I've got this, x and 15 centimeters, that's my a, and that's my a side. So I'm going to put the values in for that. I've got 15 squared equals, by the way, it's always a good idea to copy this full formula out and then drop things in, substituting in directly underneath it so that you keep track of what's going on. 11 squared plus 12 squared, those are my b and c, either way around, minus 2 times 11 times 12 cos a. So 15 squared, so I've got 225 equals 121 plus 144, 11 squared and 12 squared. 2 times 11 times 12 is 264 minus 264 cos a. If I'm using this version and trying to get cos a on its own, I'm now going to subtract these from the other side. So I've got 225 minus 121 minus 144 gives me minus 40 equals minus 264 cos a. And therefore cos a equals minus 40 over minus 264. And a itself is cos to the minus 1 of that. Cos to the minus 1 of, I'm going to leave out the minus signs because minus 40 over minus 264 is the same as 40 over 264. Type that into my calculator. Cos to the minus 1 of that is 81.2852, etc. So I'm going to call that angle A is 81.3 degrees to 1 decimal place. And just to show how this version would work with this formula, and just put things in the right place, I leave cos A equals 225. No, we've got b squared plus c squared minus a squared. So 11 squared plus 12 squared minus 15 squared all over 2 times 11 times 12. All of that gives me the same thing, 40 over 264. And from there I would be doing the same process, cos to the minus 1 of 40 over 264. So if you've memorized that version, then you should probably go ahead and use that version as long as you're secure with it. Otherwise, it's more complicated using this version, but you don't have to memorize it because it's in the formula sheet. Okay, finally find the area of triangle PQR. For that I want to use area equals half AB sine C. Area of a triangle equals half AB sine C, which is on the formula sheet. So sine C is the angle that is sandwiched between sides A and B, whatever they are. Seeing as I've calculated this angle already, I'm going to use it. So in this case I've got half times the sandwiching sides are 11 and 12, and the angle in the middle, sine of what I just calculated, 81.3. Technically I should use my detailed version, my fully accurate version. That's going to be accurate enough, I've got 4 decimal places there. So if I put that in, rather than the rounded version, that should give me the most accurate answer, or accurate enough, certainly for the exam. So sine of that times by 11 times 12 divided by 2, 65.2 centimeters squared to 3 significant figures. I'm just doing that calculator work again just to make sure. Always a good idea to do that in the exam as well. Anything that's complicated on the calculator, just do it twice. Make sure you haven't made a silly error with one of the buttons. Okay, I think that's it for that sheet. Just check that I've covered everything. Yep. Yep, that's it for the space, shape and measure one. And then check the other videos to see the other branches of GCSE higher maths for the skills that you'll need to revise for those sections of the exam.